Started. Okay, so got a little bit of trickiness in this first question. We've got fractional powers there, and we've got some other power rules. Those power rules are kind of at year 11. Those ones within the bracket, so they're not too hard. It's the fractional power that's the hard one to deal with. So what I'm doing is, because of brackets, order of operation, I'm going to evaluate what's on the inside first. And the rule we have there is that you multiply numbers together just normally. So 2 and 32 go together to give you 64. And you've got a to the 6 and a to the 3. The rule with powers, to remind you, is that you add powers when you've got the same base. Right? So it's going to be a to the 9. And that's currently to the power of 2 to the 3, because I haven't done anything with that outside power yet.
Negative.
Negative?
Yeah.
Yes, it is. That's a bit hard to spot, isn't it? So if you didn't spot that, apologies, that should have been formatted a bit better than that. It's quite tough. Alright, so there are two things there then. There is the negative, which means the same as a reciprocal, to flip something over, which we'll deal with, and there's also the 2/3, how we handle a power of 2/3. What I'm looking at doing is taking this power to both the things that are inside the bracket, okay, to the 64 and to the a to the 9. Now you can quite simply go, simply perhaps not, 64 to the power of, and I'll just type that in, negative 2 over 3. Okay, that'll do all the work for you with the number. Not very nice. See if I can turn it back into a fraction. So F to D button will turn it back into a fraction for me. So 64 to the power of negative 2/3 is the same as 1 over 16. Okay, a to the 9 to the power of 2/3, that's basically a power of a power. Alright, power of power means that you can times them together. So I'm going 9 times negative 2/3. Okay, which comes out to minus 6. You may not have needed a calculator for that. So a to the minus 6 is the other part. Now it does say a positive index up here, so I can't have a to the power of minus 6. I have to write that in another form, and the rule is that things that have negative powers can be transferred to the bottom and become positive powers. So the better way to write this is 1 over 16 a to the power of positive 6. Okay? Any questions with that? So that's a U, achievement mark. Now, question B is an achievement 1 too. It's got a few points for errors, but generally you guys did a pretty good job of keeping track of everything there. It's 3 brackets to expand. You want to do 2 at a time and then multiply the remaining bracket after that. So I will go through that a little bit quickly. I'm going to choose to do the first 2 brackets first. So it's going to be x times x is x squared. It's going to be x times positive 3 is 3x. It's going to be negative 2 times x is negative x. So if I combine those two like terms, I end up with positive x. Alright, so that was negative 2 times x and 3 times x. The last bit to multiply is the negative 2 and the 3, which is negative 6. So far, the first 2 brackets combine to be that bracket. I've still got the x plus 1 to multiply by. Okay, so same deal. Everything in this bracket gets multiplied by x, and everything in this bracket gets multiplied by 1 as well. Power gets larger when I multiply by x. Alright, so that's all the first terms multiplied by that thing there. And now I'm going to do it by the 1 as well. Multiplying by 1 gives you the exact same thing you had before. So it gives me x squared plus x minus 6. Okay, and then from there all I want to do is simplify any like terms. So I've got a x squared and a positive x squared. So x cubed plus 2x squared. And I've got a minus 6x and a positive x. So that turns out to be minus 5x. And don't need to do anything with that, it just attaches itself on the end there. So yeah, achievement mark, pretty easy to make some mistakes within there though. C I think is a merit question. I might have to look that up later, sorry, but I think it was a merit question. There is, on first glance, there is no simplification that can be made. You can't delete things from the top and the bottom because of all the addition and subtraction that's in there. So what I'm going to do is try to turn these into multiplications, basically to factorize these into two brackets, the top and the bottom. Not the easiest things to factorize, but I'm predicting that that top one's going to be 2x at the front of one bracket and x at the front of the other. Okay, that's the only way I can really make 2x squared. But also that last number, minus 2, the only ways I can make minus 2 through multiplication is by using a 1 and a 2 and have to figure out which is going to be positive, which is going to be negative. So it's either 1 here or 2 here, and I'm not quite sure where the positives are going to be. So this is just a trial and error approach I'm going for this time. So I'm going to try 1 there and a 2 there, just as a complete guess. Alright, one of them's going to be positive, one of them's going to be negative, so let me see. 2x times 2 would give me 4x. That's not going to work. So I'm going to try a minus there and a plus there and see how that goes. Alright, 2x times minus 2 is minus 4x, that's quite useful. And an x times a 1 is a positive x, that works. Okay, so I got a bit lucky there, I guess. That's what the top line is. Alright, but the second one has a few more options to it, so I'm going to try that a times c method, where you take the first number and you times it by the last number and you use that to do the grouping, just so you've seen both examples as well. So 3 times negative 4 is negative 12. Alright, so that means I'm asking for numbers that multiply to give me negative 12, but when I add them, they give me minus 4. 6 and 2 coming to mind? Okay, 6 and 2, one of them is going to be negative, it's got to be the 6 that's going to be negative. Alright, so negative 6 and 2 are the numbers that I'm going to use. So what do? We pull this bottom thing apart. The middle term gets broken up into a minus 6x and a positive 2x, because that's the same as 4x. And the last number and the first numbers are the same as what we started with. Alright, and that allows us to use grouping. So if I group this, I can say a common factor to those two is the 3 and the x. And 3x would need to be multiplied by x to give me the x squared. And 3x would need to be multiplied by negative 2 to give me the 6x. The second two terms grouping there, any common number I can use or letter, just a common number, it's a 2. And that needs to be multiplied by x to give me 2x, and it needs to be multiplied by negative 2 to give me the minus 4. And it always feels a bit like magic when you notice that both those brackets are the same, so it's going to work out for me. Alright, so the final factorization is 3x plus 2 bracket x minus 2. Okay, so I've done a bunch of work in a weird place, but what I've realized is that I have 2x plus 1 on the top, bracket x minus 2, and 3x plus 2 on the bottom, and an x minus 2. And the order wouldn't matter if I've got these in a different order. I see there's an x minus 2 on the top and the bottom, so those can cancel. Alright, so that was worth a merit mark. If you had factorized these and maybe made a mistake along the way, you'd still get an achievement mark. So you can pull achievement marks out of some of the merit and excellence questions still. Okay, questions? Okay, moving on. I thought this was a little easier, this question D part 1, but not everyone got it as well. There was a little bit of simplification you need to show there. So rearranging the equation, and they want us find a formula for finding the radius. So we want r to be the subject of the formula. So we start moving stuff away from the r to the opposite side. So the first thing I would do is I would triple everything to get rid of the third down the bottom here. So 3v is equal to 4 pi r cubed. And then I would get rid of the 4 and the pi. I can get rid of them at the same time if I want to, because they're both being multiplied by the r, so they can both get divided to the other side. So if I divide them over, we get the 3v that was already over there divided by 4 pi. That must be equal to r cubed. Okay, and the final step is to get rid of the cube. The way you get rid of a cube is a root. So r is equal to the cube root of 3v over 4 pi. If you wrote v, how does it go, 4 over 3 pi cube root, this is still right, but it's not as simplified as the one that I've done. So if you did manage to get yourself to here by dividing by 4/3 at the start, you'd want to say dividing by a fraction. Dividing by the fraction is the same as timesing by its reciprocal, so you can move that 3 to the top of the fraction. But if you've done it my way, you don't sort of have that problem. So that's just an achievement question again. Alright, and a little bit more, yeah, it's on the same page as you. So if the sphere's volume is 35 centimeters cubed, use the formula from part 1 to find the radius of the sphere. So it's simply a matter of putting 35 into that. 3 times 35 over 4 pi cube rooted. And I will actually type that in. So cube root 3 and then that symbol. And there's a bunch of stuff going within that symbol, so I'm going to use my brackets. In fact, I might even use multiple brackets. And pi button, if you know where to find that, on the graphics calculator, it's down the bottom here. I think on the older ones, it's in a similar place too, it's down the bottom of the calculator. Okay, close all my brackets. 2.029. Doesn't tell me anything about rounding in the question, so I get to choose whatever I want. I'm going to go with that. Answer done? Not quite sure I'd get my full marks for that. What else could I do to improve this answer? Units, yep. Okay, so this is finding a radius. What do you think that radius would be measured in? Could be meters. I've crossed out some of the information, unfortunately. It says centimeters cubed was the number I was working from, so centimeters is what the radius must be measured in. Right? And you could also state your rounding here too, like 3 dp or 4 significant figures, or if you chose something else. Alright, so I might just stop the video there so that you don't have a massive long thing to